What's up? My name is Matthew, and in this video we're going to talk about complex fractions. And there are a couple of different ways that you can go about organizing the process of simplifying complex fractions. I'm going to show you one of them. Just realize that there are others out there. To get this process started, the first thing I want to point out is that we have multiple numerators and multiple denominators. And what I like to do is, let's zoom in on one of these. What I like to do is call this my big numerator and this my big denominator. And what I do is, in my big numerator, I get a common denominator so that I can add those two terms together. In the big denominator, I will make a separate common denominator so that I can add those two terms together. And then what we'll have is a fraction divided by a fraction. Once we've got that, we can use keep, change, flip. In other words, multiplication by the reciprocal. And then we'll simplify as best we can, and whatever we're left with, we're going to present that as our final answer. So that's the outline of the process. Let's look at a few examples. In this one, now, as I said, there are a couple of different techniques, and within this technique, there are a couple of ways to stay organized. You could come down here and work with just your big numerator. So I'm going to write this as 9 over 1 plus 3 over v, and I'm going to turn my gain down a little so it doesn't sound like I'm yelling. Let's see if that's a little better. And the common denominator between these two fractions is definitely v. So I need to take my first fraction and multiply it by v over v. And as I believe I mentioned in my previous video, common denominators are achieved using my favorite trick. I've decided this is my favorite. My favorite trick is multiplication by 1. It's such a great tool, and here you're seeing it. V divided by v is equal to 1. When you multiply by 1, you change what the thing looks like without changing its value, because we know that multiplying by 1 doesn't change the value of anything. But what it does allow us to do is write that first fraction as 9v over v. The second fraction is still 3 over v, and we'll write that now as one fraction, 9v plus 3, all divided by v. Maybe we put a circle around it, and that is our big numerator. Let's move now into the big denominator. And that is equal to v over 4 plus 1 over 12. The common denominator here is 12, so we'll use my favorite trick again. We're going to multiply by 1. This time, the number 1 is going to look like 3 over 3. So here we are, multiplying by 3 over 3 times the v over 4. Oops, we're not ready for an equal sign just yet. Bring along that plus 1 over 12. Now we can start to clean it up. Our first fraction becomes 3v over 12. The second fraction is still 1 over 12. And we can write that all as one fraction now. 3v plus 1, all divided by 12. So there's your big numerator and big denominator, and they've almost ended up one right over the other, which is perfect. And if you want to, if you've got space, you may do that. So I'm going to write big numerator over big denominator equals, and then here's my big division symbol. The numerator is 9v plus 3, all over v. The big denominator, 3v plus 1, all over 12. And what we have here, as I mentioned, is a fraction divided by a fraction. And one of the best ways to deal with that scenario is to change the large division that we have going on here into multiplication. And the fraction, in this case that we're dividing by, we're going to use its reciprocal. Some of you know that as keep, change, flip. Some of you know that division is equivalent to multiplication by the reciprocal. So here's my new multiplication symbol. Here's the reciprocal of my denominator, 12 over 3v plus 1. And sometimes this multiplication problem right here in the middle of the screen, now it's moving toward the left of the screen, that can be simplified just by, starting to cross some things out and canceling something here and canceling something here. But in this case, it's not quite that easy. What I'm going to do now is, and you should write yourself a note if you need to remind yourself, you can call this keep, change, flip. You can call this, that was supposed to be an arrow. You can call this multiplication by the reciprocal. So even though I'm not writing out some little annotations, make sure that you're taking notes on this process. And the next note you'll want to include maybe is that I'm going to take my first numerator and I'm going to factor it. I'm going to factor out a greatest common factor, and that's a multiple or a factor of 3. So now I can write my first numerator as 3 times 3v plus 1, close, times the 12 from the second fraction, all divided by, I've got a v in my first denominator and a 3v plus 1 in the second denominator. So while I did take this 9v plus 3 and factor it, turning it into this, the other thing I did is, and you should know this already, is that in order to multiply two fractions together, like these two, you can multiply the numerators and multiply the denominators. That's why they're appearing here in one large numerator, and the product of my denominators is appearing down here as one big denominator. I find that that also makes it easier to see the reducing that you're now allowed to do, which is happening here. This 3v plus 1 and this 3v plus 1 are going to cancel out. And then we'll do the multiplication, leaving us with a final answer of 36 over v. And that is the process of simplifying a complex fraction. There are other complex fractions that are a little bit more complex. This one still, the general idea, the general process remains the same. Isolate the big numerator and the big denominator, excuse me, come up with a common denominator for both of those, and then once you've got a fraction over a fraction, keep, change, flip, and simplify. Let's work through this one as an additional example problem for you to have. And I think I'm going to, I'll try a different sort of organizational approach. I'm going to keep this as one sort of package deal all the way across. And we'll undoubtedly have to wrap onto the next line, but that's okay. So there's my big division symbol, and I'm going to change the number 1 in my numerator here and write it as w squared over w squared. Anything divided by itself is equal to 1, which is perfect because that's what that is. It's a 1 minus 4 over w squared. And we've got ourselves a common denominator. Let's wrestle with the numerator the big denominator. Let's wrestle with the big denominator for a second. The 1 in my big denominator needs to have a common denominator down there, also of w squared. So I'm going to write that number 1 as w squared over w squared minus, now the 2 over w, it needs to have a denominator of w squared. So I'm going to multiply the numerator there and denominator by w. So 2w. And if you want, you could write it as, let's see, what order did I do it in the previous problem? Creating the common denominators in the previous problem, I was putting these multiples of 1 first. So why don't I do that down here? Let's get rid of this. I'm going to multiply by w over w times the 2 over w in order to get that common denominator. And finally, the 8 over w squared. All right, so remember, the goal here was to create a common denominator in the big numerator and a common denominator in the big denominator. In this case, those two common denominators were the same. We're trying for a w squared on the top and on the bottom. Okay, let's slide that over a little. And now in the numerator, the big numerator, we already have a common denominator, so we can write that as w squared minus 4, all divided by the common denominator of w squared. And in the big denominator, look at this. Here I've got a denominator of w squared. Here I've got w times w, which makes w squared. Here I've got a w squared. So we do have a common denominator in the big denominator. And I'm going to sort of multiply these fractions together in my head. I've already multiplied those denominators to get a w squared. I'm going to multiply the w and the 2 now in the numerators and simply write that as 2w. Let me show you. I'm going to start with this w squared right here, and then minus the 2w that I just mentioned, and then minus that 8, all divided by the common denominator of w squared. Very nice. All right, so this w squared is this w squared. This w times 2 is this w times 2. And the 8 is the only 8 on the page, so it must be that one. All right, make sure that you're comfortable with how those pieces match up. And we now have a fraction divided by a fraction, so we can start on that next part of the process, which is the keep, change, flip part, or the multiplication by the reciprocal. Keeping my big numerator, w squared minus 4, all over w squared. My w's don't look very good when I write with this digital pen. I apologize. And then let's use the reciprocal of our denominator. So the w squared is going on top, all divided by w squared minus 2w minus 8. Let's try that 8 one more time. There we go. And now, can we start simplifying or cross-canceling? And by cross-canceling, that's a term that I've heard some students use when they when they cancel across a multiplication sign like that. Some students I've heard refer to that as cross-canceling. Really, we're doing a fraction times a fraction here, which is going to allow us to multiply the numerators and denominators together, which means we should be able to just think of this as one big fraction. So you're not really cross-canceling, you're really just canceling. But call it what you will. Initially, I see that I can let these go. So I am going to reduce or cancel those out. The other thing that I'm going to do is I'm going to factor this numerator, and I'm going to factor OR. There we go. Factor that denominator. So the w squareds are already gone. I think I'll move down here a little bit. This shouldn't take us too much longer, maybe a couple more steps. Equals w squared minus 4 is a difference of squares. It factors into w plus 2 times w minus 2. And the denominator factors into w minus 4 times w plus 2. And what that allows us the opportunity to do is cancel out one more common factor from the numerator and denominator. That's the w plus 2 and the w plus 2. And we can write ourselves a final answer of w minus 2 over w minus 4. Amazing to think that that initial expression reduces all the way down to these two very simple polynomials, one on top of the other. I don't mind that. taking a big mess and turning it into a small one. Nicely done. Are there any other variations that we need to consider here? Here's another variation. In this case, the big numerator, let's just punch in on this a little bit. In this case, the big numerator has a denominator that's not just a number or a variable, it's an expression with a couple of terms in it. The denominator up there is x minus 2. And the big denominator, as I throw my pen at the table, my big denominator isn't a fraction at all. We could think of it as x minus 3 over 1 if that's helpful to you, and that's not a bad idea. But yeah, this one looks just a little bit different. However, we're going to stick with the plan of creating a common denominator on the top, common denominator on the bottom for the big numerator and big denominator respectively. And then once we have it as a fraction over a fraction, we will keep change flip, multiplying by the reciprocal, and we'll simplify as best we can. Let's see what happens. I liked that previous strategy of just kind of keeping everything bundled together, keeping this big fraction moving along together all at the same time. So let's get ourselves some divisions set up there. And this time, as I mentioned in the numerator, you've got a denominator of x minus 2. So I'm going to take this x right here. I'm thinking of it as an x over 1, but it needs to be, or needs to have a denominator of x minus 2. So I'm going to multiply that x over 1 by x minus 2 over x minus 2 times the original x over 1 minus the second original term up there, which is x over x minus 2. So this fraction didn't change at all. It's still right here. Here's the original x minus 1 and x minus 1, and here's my favorite trick, multiplication by 1 in order to achieve a common denominator. Put that back. Where'd that go? Oh boy. If I click the backspace button too many times, it just starts erasing everything. Excuse me. All right, apparently I can't just selectively erase. I was circling too fast. Let's just erase a little bit of this clutter. All right, that's as good as it's going to get, I think. Well, this was not originally. I didn't write that, so it'll be easier to erase. Okay, let's start from there. In the denominator, there's no work to do. It's just x minus 3 over 1. So the hard work that we have to do on this one is cleaning up the big numerator. We're already making some nice strides. Equals big division. Now really, we have our common denominator in the big numerator already. So I'm going to multiply these numerators together. I'll write that as x squared minus 2x. And then this minus sign is going to come over here, minus, and then this x, all divided by the common denominator of x minus 2. All divided by x minus 3 over 1. So again, in the big numerator, I multiplied this x times this negative 2 and this x times this x, giving me this x squared minus 2x. That's where that came from. Keeping that. Okay. Let's combine like terms in the numerator. The numerator's numerator. Let's combine like terms right there before we drop down to our next line. Equals, I've got x squared minus 3x all over x minus 2 all over x minus 3 over 1. So all I did was combine like terms right here. And now I'm going to factor. I'm going to factor this x squared minus 3x. that numerator's numerator contains a common factor of x. So I'm going to factor it out and write this as, just move up there a little, equaling, here's my big divisor, numerator's numerator is now x times x minus 3 divided by x minus 2. Let's throw a minus in there. There we go. All divided still by the x minus 3 over 1. And now we have ourselves a fraction divided by a fraction. We could have, so I'm about to do keep change flip. I'm about to multiply by the reciprocal. We could have done that in the previous step right over here. Here you might have said, well, I already had a fraction divided by a fraction. For that matter, I had a fraction divided by a fraction here. Why didn't I do the keep change flip process right then? You could have, but you still would have had to combine like terms in here, CLT. You're still going to want to factor, but you could have done the keep change flip earlier and done the combining of like terms and the factoring later. That's just the order in which I chose to do it. Okay, so now let's keep change flip. Keeping my first fraction of x times x minus 3, dividing by the x minus 2, multiplying by the reciprocal, that's 1 over x minus 3. And finally, there's nothing that we have to do before we reduce this multiplication process. X minus 3 divided by x minus 3, whether you want to cross them out or circle the things that you're canceling, those are going to go. And I think we can even fit our final answer right on this same line. That is x over x minus 2. Close that box. There we go. Looks a little rough. X over x minus 2 is our final answer, and I'm pretty sure that is going to give you as comprehensive a look at the process of simplifying complex fractions as you're going to need. Number 4 is simply a sort of amped up version of the previous problem that we did. You still need to create a common denominator on the top and on the bottom, allowing you to do, in this case, subtraction here and subtraction here. And once you do that, you're going to have a fraction over a fraction. And you'll probably want to combine like terms, or at the very least, you're going to want to factor, and then keep change flip, and then cancel out what you can, okay? Just because the problem looks a little bit different. In this case, when you're working with complex fractions, you're probably not going to need to deviate from the plan very much. Some variations here and there, but nothing too big. Let's start this process. I'm not going to take this problem all the way through because I don't think you need me to, honestly, but it might be nice to have just a little bit of help getting started. In the numerator, the common denominator is going to be x minus 2 times x plus 2. So I'm going to take my first fraction and multiply it by x plus 2 over x plus 2. So you see now that when we write this as one fraction, the denominator is x plus 2 times x minus 2. All right, here's our primary minus sign in the numerator. And I'm going to take my second fraction and multiply it by x plus 2 over x plus 2. I lied, x minus 2 over x minus 2. Times the original fraction, 4 over x plus 2. You can see now here that when we multiply those fractions together, the new fraction will have a denominator of x minus 2 times x plus 2, which is the same as the denominator we created by multiplying those fractions together, which means we have just created a common denominator. Let's go through the same process in the big denominator. Let's multiply our first fraction by x plus 4 over x plus 4 times the original 2 over x plus 3 minus multiplying this time by x plus 3 over x plus 3 times the original fraction, 3 over x plus 4. I love that I got to use my favorite trick 4 times in one problem. This is multiplication by 1, this is multiplication by 1, here's multiplication by 1 again, and there it is again. All in an effort to create common denominators in the big numerator and in the big denominator. Now, in my big numerator, I'm going to multiply these, and then I'm going to put a minus sign, and then I'm going to multiply these. For starters, 3 times x plus 2 minus 4 times x minus 2. I did kind of change the order a little bit, okay, but all of the correct factors are there from those two numerators. And then the common denominator is, it doesn't matter what order you write these, x plus 2 times x minus 2. In the denominator, let's multiply these numerators together and these numerators together. We'll separate them by a minus sign, and we'll write it over the common denominator. That's a 2 times x plus 4 minus 3 times x plus 3, all divided by, order doesn't matter here, x plus 4 times x plus 3. Perfect. Now here's what I want you to do as you take over this problem. Distribute your multiplication by 3, distribute multiplication by -4, distribute multiplication by 2, distribute multiplication by -3. So let's make a to-do list for you. You're distributing. Then I want you to combine like terms to the best of your ability. And then I want you to factor those numerators, the big numerator's numerator and the big denominator's numerator. So once you factor those, then I want you to keep, change, flip, and then I want you to reduce or cancel, whatever you can. And that will be your final answer. Now, of course, you have homework assignments that you're going to be working on after watching this video, or that you've already started working on, and hopefully these organizational strategies are going to allow you to be more successful as you complete your homework assignment. So with those strategies in place, I'm going to get out of here. Just kidding. But really, I am going to get out of here. I do have another section that I'm going to prepare and post right after this one, so I've got to get set up for that one. This should get you started. Stay organized, sharp pencil, use lined paper, and use the lines that are on the lined paper, please, to help you stay organized. Staying organized in these problems is key. Organization is key. Okay, now I'm just talking to talk. I'm out of here. See you later. Thanks.